So here we go. Here is the next lesson that is there in your syllabus, which is a periodic table. That's actually the first lesson in your second term or second semester, whatever you call that. So this is the first topic, periodic table. This is the most important topic as we will be looking into how, because periodic table is basically the fundamental, where you find all the elements and how are the elements classified and what are the few of the main features in the periodic table, right? So I'm having a technical error. Let's see. Yeah. Okay. So the learning objectives that we will learn. So once we are done with this recording, you will know what a periodic table is. Okay. And then we'll discuss about the features of the periodic table, and also we will look into how to represent an element. Okay, so in the previous video we discussed about what an element consists of, but here we will look more in detail about how these basically we're looking into how electrons are distributed or how they are configured in a particular element. All right, so let's start. Okay, so first of all, let's look into the periodic table. So periodic table, as you know, okay, as you can see, periodic table is basically in your chemistry book, it would be either at the back of your book or either in the front of the book. I'm not really sure where the periodic table is in your textbook, but you would see a particular diagram like this, which is a pretty colorful, sometimes not colorful, but here we have found a very colorful representation of the periodic table. So there are a lot of different symbols, right? There are different symbols and different shapes in which they have been placed. You can see this like you can see this tower is much more taller than this one, and then there are horizontal. Here there are there are different kinds of patterns in which they are arranged in. So we look into how and what basically what these columns and the rows, what do they represent? Okay, so as a normal table, periodic table also consists of rows and columns. Okay, any table consists of rows and columns. Okay, so but in chemistry we define rows as periods. Okay, so in chemistry a period is the row. So these are periods. If you see, these are periods. All the horizontal things are going to be the periods. Okay, so if you see here clearly, okay, so here how the period starts is this is the first period. So this first period contains only two elements, this H and this HE. Okay, so this is the first one, and then so on it goes, second one, third one, fourth one, and it goes all the way down. Okay, but for your syllabus we need to only know the first four. Okay, so from if you start from here, if you start from this hydrogen, you go here, here, here until this guy. Okay, so you need to know only the four, but you need to remember what rows are, and we represent rows using normal numerals. So normal numerals means normal digits, numerical digits that you use in your day-to-day life, like number 1, number 2, number 3. Okay, so nothing extraordinary there, just normal numerals. Where in the sense, now we spoke about the rows, let's speak about the columns. Okay, so columns are these vertical bars. These are the vertical bars. Okay, all these are the columns. In chemistry we call these columns as groups. Okay, so there are basically 7 groups. So this is one group, second group, third group, fourth group, fifth group, sixth, seventh, and eighth. So 8 groups in total. These middle guys, they don't fall into any group. They fall into another category called transition metals, which you don't need for your syllabus. You will learn it in your upper grades. Okay, so just remember that there are 8 groups in the periodic table. Okay, and these groups are represented using Roman numerals. So when we say Roman numerals, they are you have seen a Roman numerals. So for example, how to represent number 4 in Roman numeral is you put I and a V, something like that. So group 5 you have to represent using V. Okay, so those are the few things that you need to keep in mind, and because those are very really important. So in case in a question, if they're asking you to which group a particular element falls into, and you say you know it falls into group 5, but unfortunately you have written the normal numeral instead of the Roman numeral, then you don't get marks. Okay, so those are small things that you need to um, pay attention to. Okay, so that's about the rows and the columns. And then you must be wondering how these elements are classified. Now, why is hydrogen here? Why is aluminium Al here? Okay, so something like that. So this is all depending on the atomic number. Okay, they are arranged according to their atomic number. So basically, from the left to the right, the atomic number increases. From top to bottom also, the atomic number increases. So atomic number, to recall what atomic number is basically the proton number or the electron number of an element. Okay, simple as that. So if you see here, so this side, the atomic number will increase. From this here, left to right, the atomic number will increase. From here, left to right, the atomic number will increase. So how do they jump from one row to another row? I'll tell you that also. So for example, when you come here, you can see it's number 10 here, right? Yeah, and I forgot to say where the atomic number is, right? So let me tell where the atomic number is. So this is a particular complicated periodic table. Okay, the periodic table that I have seen in your textbook contains only the symbol. Okay, it contains only the symbol of the element and a number. So that number that it contains is the atomic number. Okay, so you don't have to worry about too many numbers in your case, just only one number. That one number represents the atomic number. Okay, so here if you go here, okay, now we were talking about switching rows, right? So how do we go from one row to another row in terms of atomic number increase? So here if you go here, you have number 10. So the atomic number is 10 for this element Ne. So once it goes here, we can see Na has an element of 11. So that's the way. So always it will go here and it will increase. Okay, so that's the way. It always increases by 1. Always increases by 1 from left to right. Okay, but if in case of say from top to bottom, if it increases, if you can see it also increases, but it doesn't increase in a regular pattern. It differs. All right. So atomic number, the elements are arranged based on their atomic number. We could also be more specific, saying it to be on the they are arranged according to the increasing atomic number or proton number or electron number. All three are synonyms of each other. Okay. Then we go to the next part, which is we will look into how to represent an element. So representation of an element is very important. Okay, so if we recall what we did in atomic structure. Okay, we said in atomic structure that an atom consists of electrons, protons, and neutrons, and we identify and we located the places in which they are arranged. So for example, electrons are arranged away from the nucleus, whereas in the nucleus you find the protons and the neutrons. Okay, but here when we represent an element, okay, we aren't bothered actually about the protons and neutrons. Neutrons actually we're not bothered about it. Even the protons we don't care about them. The only thing that we care is about how the electronic configuration or how the electrons are arranged. So because of that, because we consider only the electrons and we have kicked out protons and neutrons, we basically say the representation of an element we can straight away call it as electronic configuration. Okay, because we just show only the we only show the electrons arrangement. Okay, and then you will notice once I show you the example, there will be circles. Okay, there will be circles because these electrons we will be placing in circles, which we called as electronic shells, or you can normally just call it as electron shells. Okay, but there is a small rule in which we can fill these electronic shells with electrons. Okay, so be very mindful about this one. The first electron shell can only contain 2 electrons. So the first electron shell or the first circle can only contain 2 electrons. That's a must. That's a definition. Even if you go to another country, that will be the same. That's a fact. But whereas the other ones, second shell, third shell, fourth shell, and so on, it can you can fill up to 8 electrons in those shells. Okay, so let's look at what are these shells and what are these. What am I talking about? This how do you? Okay, so here we go. So we have I've shown here. I don't know, three examples: lithium, magnesium, and potassium. Okay, so these are the shells. These circles are the electron shells or the electronic shells. See, okay, and these representations, these circles are the ones that we circle and the crosses are the representations of the electrons present. Okay, so the standard way of representing electron in chemistry, you either write a put a dot or you put a cross. Okay, you can't represent it in a combination. Like for example, if you want to represent the electrons in lithium with dots, you have to stick with dots. You can't put a combination of dots and crosses. Okay, so you have to stick to one. If you started with dots, continue with dots, or if you started with crosses, continue with crosses. Okay, so now that is that. Okay, that's electron shells and how to represent. Now, how to fill these electron shells? That's the most important thing. Okay, so here we can see lithium is already, this is a proton number, so proton number is 3. Okay, so that means lithium has 3 electrons. So how are we going to put these 3 electrons into these electron shells? That's the whole point of this. So the way we're going to do is we're going to remember our theorem. Okay, what's the theorem? The theorem says that the first electron shell can contain only 2 electrons, but this guy has 3, so we can't put all 3 into the first electron shell. So then what do? We go by the theorem and we fill the first electron shell with 2 electrons. Okay, then out of the 3 electrons of lithium, 2 are already we are put into the electron shell. Then we are held by only 1 electron which is remaining. So where do we put that 1 electron? We can't put it into the first shell. So we move on to the next shell, which is the second shell. In this case, this is the outermost shell or the last shell. So we have put 2 in the first shell and we put the last electron in the last shell. Okay, so basically what did we do? We first filled the first shell, we came up to its maximum, and then we moved on to the next electron shell. So the maximum on the first electron shell is only 2. All right, let's go to magnesium. So in magnesium, we can see that the proton number here is 12. So magnesium proton number, or the atomic number, is 12. So how do we do this? How do we represent this? Follow the same theorem. First of all, try fill in the first electron shell. So first electron shell, as you know, we can only put 2 electrons. So you put the 2 electrons. So you put the 2 electrons. That's done. Next we go, because now we have put 2, that means we are remaining with 10 more electrons which we have to place into this electron shells. So how are we going to do? Now the second electron shell also can have only a maximum of 8 electrons. Okay, that's a must. That's a fact. So let's fill the 8 electrons in that. So once we fill all those 8 electrons in the second shell also, we see that we are again there are another 2 electrons that are remaining. So where do we put those 2 electrons? We can't put it into the first shell, we can't put it into the second shell, so we have to go to another shell, which is a third shell. In this case, the third shell is the last shell. So we will put those 2 electrons in that third shell or the last shell. So that's the way this has come. All right. Similar for potassium. So potassium, what has happened is we follow the same theorem. Fill the first shell. We can only fill with 2 electrons. We move on to the next shell, which we can only fill how many? We can fill only 8 electrons. Then we are done with 10. We have 9 more to go. So we go to the third shell and we fill that also by 8. After filling that third shell, so we are left with 1 electron. So the 1 electron, where do we put? Are we going to put it away? No, we are going to put it into this electronic configuration by adding another electronic shell and putting it into that particular shell. All right. So basically, you start with the first electron shell, see whether the maximum number of electrons in the first shell is met, which is 2 electrons. Go to the next one, see whether that is also met, then you go on adding. So basically, first electron shell you can fill up to 2, second electron shell you can fill up to 8, third, fourth also you can fill up to the 8th electron. If there are more electrons, then you go on adding more and more electron shells. Okay, and this wordings in numbers in red, what do they represent? So basically they represent, so 2 basically means that the first shell contains 2 electrons, and the last so basically there are 2 electronic shells here. The first one containing 2 and the second one containing 1. Okay, so here you can see you have 3 electronic shells. The first one contains 2, second one contains 8, and the last one contains 2. Similarly, for the potassium one, you can see there are 4 electronic shells. First one containing 2, second one containing 8, third one containing 8, and the last one containing only 1. All right. So that is the simple idea. So the best way where you can practice these is just go to refer to your textbook. There will be your periodic table and try to draw the electronic configuration for some of the elements, random elements. It could be any element, just you need the symbol of the element and you need the atomic number. So once you know the atomic number, once you know the element, just try to practice by drawing these electronic configurations. If you have any doubt, just forward it to me through WhatsApp. All right. Then, now the other thing that we need to know is how are we able to classify these elements into groups. Now I told you that now you could have seen in the periodic table that a particular group will have particular elements. So how are those elements classified into those groups? That's a very important thing that you would need to know when we discuss the next chapter also, and for so on. When you go to a higher grade, you will need to know what are those things. So here we will just brief out how we are able to classify them. Okay, so the elements are classified into groups based on the theorem as stated below here. So here we say the number of electrons in the outermost shell or the last shell will determine the group of the element. Okay, so it's more easy for us to explain by an example. So I've taken an example of element named A. So I say it contains 2 electrons in its outer shell, so it falls into the second group. So it falls into group 2. Okay, another example, say we have element B. It contains 5 outer shell electrons, or it contains 5 electrons in its outer shell or the last shell, so it falls into group 5. So I've done this example, magnesium. Okay, this magnesium, Mg is magnesium. So here you can see in the outermost shell or the last shell or the third shell of this element, you can see there are 2 electrons. So that means magnesium should fall into the second group. So you can verify it by checking the periodic table. What I have said right now, whether it's true or not. Okay. So we know about groups, similarly, we'll talk about these periods also. So how are these elements classified into periods? That's also we need to know. Is also there's a small theorem. We'll learn about the theorem. The theorem says the number of electron shells equals to the number of hang on, I got it right. I got it right. The number of electron shells equal to the period number of that element. So basically, if you take an element, say element A, if it contains 3 electron shells, it falls into the third period. Take an example, element B contains 2 electrons and it falls into the second period. Okay, so basically the number of shells, just how do you know the number of shells? Just count the number of shells. So in this example, potassium is K is potassium. There are how many shells? 1, 2, and 3. So into which period should it fall? It should fall into the third period. If it doesn't fall into the third period, that's a mega pardon. Am I wrong here? Yeah, I'm wrong. So I said 3. I forgot. I didn't see this one. So let's do it again. So potassium has 1, 2, 3, and 4. So it has 4 electron shells. So that means it should fall into the fourth period. Okay, so if they had given you another element and it had 3 electron shells, it will fall into the third period. So similar to that. Okay, so 1 electron shell, it will fall to the first period. Okay, so that wraps up our discussion about this particular topic, which is periodic table. So we learned about what periodic table consists of. Then we spoke about rows and columns, and now we spoke about how elements are being classified into rows and the periods, and also we spoke about how to represent an element, which is in other words called electronic configuration. So please be mindful about electronic configuration, and please, as I said in the video, find some elements in your periodic table and try to attempt in drawing the electronic configuration, which is very important. Okay, because there will be questions. I will definitely be giving you questions about that. And if you have any doubt, any questions about this, what we did today, you are free to send me a text through WhatsApp, and I will be able to clear all of your doubts. All right. So see you. I'll meet you in the next video. Okay. Thank you.